Hey race fans, welcome back to a wonderful Algebra 2 lesson you're about ready to receive. Today we're going to do section 322, which is simplifying rational expressions. So rational expressions, a rational is like a ratio, so like a number over a number, or a factor over a factor. So a fraction is what we're going to look at, and we're going to see how 1 can be useful, the number 1 can be useful. So we're going to analyze and compare these rational expressions and get a better understanding of what's going on with them. Sound good? So problem 71, Mr. Wonder claims that anything divided by itself equals 1 as long as you do not divide by 0. So problem A, or letter A, Mr. Wonder states that 16x over 16x equals 1 if x is not 0. So what's his hypothesis and what's his conclusion? So his hypothesis is pretty much saying that this number over itself equals 1, and where x cannot equal 0. So B wants to know if he is correct. He wants to know if his statement is true and justify what your conclusion is. So for B, we have 16x over 16x. And making it the long way, I mean, I think maybe by now we realize like this is 1, but I'm going to sit there and kind of like break it apart a little bit for us, just for lesson reasons, right? So technically 16x is the same thing as 16 times x over 16 times x. And if I really wanted to, I could break it down even further and do 16 over 16 as one fraction times the fraction x over x. So in our mathematical career, we're looking at all of our simplification of fractions and everything else. We know that like 16 over 16 is going to be 1 over 1, right? If we were to reduce that fraction, anything over itself is 1, right? And x over x, we know that that's going to be a 1 and a 1. So of course 16x over 16x is going to equal 1 over 1, which is going to be 1. So is he correct? Yes, he is correct. But he also adds this statement on there that says if x is not 0. So that's the part where we're really focusing on today, is that x not being 0. If we go back to this original 16x over 16x, what do we know about denominators? Right, denominators cannot equal 0, right? So we're looking at our denominator now. Oops, I'm going to put a little green circle around just our denominator, that 16x. And we know that our denominators cannot equal 0. So this cannot equal 0, right? So in order to figure it out, think of that not equals as the same thing as an equals to kind of like solve it. If we divided both sides by 16, right, this becomes 1, so we get x does not equal 0 over 16 is 0, right? So we have what's called an excluded value, and this is that whole thing about why x cannot equal 0. We know we can't divide by 0, right? We talk about this all my little apple in the basket analogy, right? If you had 0 over any number, let's say 5, right? Or sorry, I just did that backwards. We can have 0 out of 5. If we had 5 out of 0, so I have a basket of, 0 apples, and I have 5 rotten apples in my basket. So how can I have a basket that has 0 apples in it when I'm telling you I have 5 rotten apples, right? It doesn't work that way. So we know we can't divide by 0. So those are called, we can't do this. So this is called an excluded value. Right. And those are kind of like what we're looking at for today's lesson. Because if we look at D, so for D, we have x minus 3 over x minus 3. Does this equal 0? And are there any excluded values? So in mathematics, we have to be careful when it comes to looking at our problems. If we go back to B, and when we were able to say 16 over 16 was 1 and x over x is 1, the reason we're able to do that is these are factors. Factors are what you multiply by. So this 16 over 16 is being multiplied by x over x, kind of like how we have it set up in this part, right? We're separating by the multiplication, and that's what's allowing us to be able to cancel those out. The way that this is written, this is not x divided by x and -3 divided by -3. This is all like one factor, right? They're not separated by multiplication. So a lot of times when I receive problems like this, first thing I do is I throw these babies up in parentheses, right? So that the top and the bottom are in parentheses. Now when it comes to being able to cancel this out, I can now cancel the top and the bottom, that x minus 3 and that x minus 3, because those factors, that whole entire thing matches up exactly the same. I cannot go back on this problem and say, well, I can cancel x and x and I can cancel -3 and -3. That's not how it works, because those aren't factors, right? The factor is that whole piece on top, separated by multiplication. You got to remember that. Separated by multiplication is what allows us to cancel out. So because this whole thing is one number, this is one value, this is one, so that's why we can cancel those out. That whole entire thing's got to match up completely. Top and bottom's got to match completely. And then we can say that it equals 1. But we have to think of our excluded values, right? So what do we know? We know that our denominator cannot equal 0, right? So we're going to add 3 to both sides, right? So x. And if it works, you can write it as equals 3, and then just know that in the end that it cannot equal 3, right? It's your excluded value. Your excluded value. Or if you write it excluded value, right, when x equals 3. You can write it that way. So your complete answer would include all of those little good guys. Okay? E says create your own rational expression, an algebraic fraction that equals 1. So make sure you guys get that in your notes. All right, let's go through some examples. So problem 74 in our book, use what you know about the number 1 to simplify each expression below, if possible. State the values of the variable that would make the denominator 0. So there's 2 parts to this. We're going to simplify it, and we're also going to come up with those excluded values, those numbers that would make our denominator 0, which we know we cannot have, right? So if we look at A, you get 2 options. You can leave it as x squared over x squared, and we know that those 2 babies are going to cancel out, and then that's going to equal 1, right? Or if you need to, you can separate that, right? This is the same thing as x times x over x times x. Because they're being multiplied, I can cancel this guy out as 1, and I can cancel this guy out as being 1, right? So it's a personal preference on where you feel. When I look at my denominator, what's my denominator? My denominator is x squared, and I know that that cannot equal 0. So what values are going to make it 0? When x equals 0, right? That's going to be my excluded value. And you can have more than one excluded value, right? So let's look at B. So on B, x over x, it's a term over a term, so we know that's going to be 1. X over x, we know that's going to be 1. And then we still have our x divided by 3. Can we simplify that any farther? Nope. So to simplify this as far down as possible, we're going to get x divided by 3. But what do we need to look at? We need to look at our excluded values. So we got to look at our denominators. And on this one, we technically have 3 separate denominators, right? So what do I know about this first denominator? I know that x cannot equal 0. We're going to look at that second denominator. It's the same thing. You don't have to write it again, but if you want to, we can. X cannot equal 0. And I still have to look at my third denominator. So 3 cannot equal 0. Well, guess what? 3 doesn't equal 0. So we don't even have to think about that one. We can cross that one off. So what's my excluded value? My excluded value is when x equals 0. Okay? So we know we're just going to kind of keep progressing through these problems, getting a little bit harder, a little bit more spicy each time. So when we look at C, we have these two rational expressions, two fractions, that are being multiplied together, right? So a lot of times, first thing I do, throw these big guys in parentheses, right? Now you can either leave it the way that it is, or you can actually kind of combine these so that it's all under one fraction. So you could write it as, in your numerator, x minus 2, x plus 5, all over x minus 2 and x minus 1, right? So now we're looking for those factors, those things that are being multiplied by, that match up perfectly. And when I look, I see I have an x minus 2 on the top, and I have an x minus 2 on the bottom. My x plus 5 and my x minus 1, those babies don't match, so those babies ain't canceling. So what am I left with on top? X plus 5. And what am I left on the bottom? X minus 1. Right? So now I still have to look at my excluded values. So I'm going to look at my denominators. So I'm going to look at, and I have to look at all my denominators. So I got to look at this denominator and this denominator. Even though I was able to cross that x minus 2 off, in my original problem, if I were to put in 2, that baby would become 0 and I'm dead in the water, right? So I'm looking at all of my denominators. So my first denominator was x minus 2. I know that cannot equal 0. And I'm looking at my second denominator, x minus 1. I know that cannot equal 0. So this is going to give me x equals 2. This is going to give me x equals 1, right? These are my excluded values, right? Because those are the values that make my denominator 0. All right, on D, again, you can leave it the way that it is, and you can cancel out those like terms, or you can combine it together, right? So this would be the same thing as 9x over, technically x times 9, but multiplication order doesn't matter, so you could write it as 9x. So this is just like the example that we did for problem number 71. What do we know about 9? Because these are being multiplied, right? So these are factors, and we gotta look for factors that match up perfectly on numerator and denominator. So what happens with my 9s? 9 over 9 is 1, x over x is 1. So, whoops, I guess I kind of put that in the wrong spot, didn't I? We're just going to write here. So what's that going to equal? We know that that's going to equal 1. And again, I have to look at my denominators, and none of those babies can equal 0. So x equals 0 cannot equal 0. And then on the second one, 9 cannot equal 0. Well, we know that 9 cannot equal 0, right? So we don't even have to worry about that one. So then what's my excluded value? Excluded values when x equals 0, right? We always have to look at those denominators, especially in rational expressions where we have variables in the bottom. I got 4 more examples for you guys to go through. All right, so for letter E, we have h times k all over h. When I first read that, I thought it was 3 h's on top. So, like, why do they letters have very close resemblance to each other? All right. So on this one, when it comes to being able to cancel out, remember, we're looking for those things that are being multiplied together, right, to be able to cancel. So we do have an h on top and we have an h on bottom, so those babies match perfectly, so we can cancel those two out, or that h over h is going to be 1. Just know that, like, it's a 1-for-1 deal, right? If there's 1 h on top and 1 h on bottom, you can only cancel out the 1. You can't continue to cancel out these h's, right? You would need another h in order to be able to cancel those guys out. So that is as far as we are able to simplify this. So this is just going to simplify down to h times k. We got to look at our excluded values. So we're going to look at our denominator. We know that our denominator cannot equal 0. So we know that, we know that h cannot equal 0, right? So that's our excluded value. So our excluded value is when x equals, it's not an x, it's an h. I'm killing this problem, aren't I? When h equals 0, right? All right. Let's move on over to problem F. So problem F, they sat there and they ended up giving us all of these in parentheses already. So they give us all the factors, so the 4 factors. And we know that it's a factor because even though it's not marked, there's actually multiplication symbols in there, right? So in order to be able to cross these off, our factors, the things that we're being multiplied by, have to match perfectly. So this whole guy would have to match perfectly with somebody in the denominator. Or this whole guy would have to match somebody in the denominator to be able to cancel those out or for it to equal 1, right? So that 3m minus 5, there's no 3m minus 5 in the denominator, but I do have an m plus 6 and an m plus 6. So m plus 6 divided by m plus 6 is going to be 1. So what are we left with? In the numerator, we're left with 2m minus 5, and in the bottom, we're left with 3m plus 1. Like always, because we have rational or fractions, we got to look at our denominators, and we know that our denominators can never equal 0. So we're going to look at each one of those. So I know that m plus 6 cannot equal 0, and I know that 3m plus 1, that one cannot equal 0, right? So I'm going to subtract 6 from both sides on this first one and get m equals negative 6. And then on the second one, 3m, I'm going to subtract 1, right? Cannot equal negative 1. If you want, you can leave it as equals and then just know at the end not to put not equals. And then I'm going to divide by 3, so m cannot equal negative 1/3. So those two are going to be my excluded values. Right, because those are the values that make my denominator 0. All right. Spicing it up a little bit for problem G. G ends up giving us this 6 times the quantity n minus 2 squared, right? And technically this one is to the first power, so there's not the same amount on the top and the bottom. So you can write this out, expand it. This is the same thing as 6 times n minus 2 times n minus 2, right? Because anything that is squared is you're just multiplying it by itself. And then in the denominator, we have 3 over n minus 2. So now we want to go through and try and simplify this as much as possible. So I'm going to start by looking at my 6 over 3. And does my 6 over 3 simplify? Yeah, it simplifies. 3 goes into 3 once, 3 goes into 6 twice, right? And then now I'm looking for those factors, top and bottom, that would be able to reduce to 1. And we have an n minus 2 and an n minus 2. And that's going to give us 1. And we can't do anything with this n minus 2 because we don't have another n minus 2, right? So what do we have on top? We have, don't forget our 2, and then we have n minus 2. And our whole denominator has simplified out. But we have to look at our denominator to see if we have any of those excluded values, right? So we would have where 3 cannot equal 0 and where n minus 2 cannot equal 0. This one we can just ignore, right? Because you can't change a variable. There's no variable. And this one you're going to add 2, so we know that n cannot equal a positive 2. Right, so that would be my excluded value. Right? And that would be the simplest form. Right. And then the last one on H, again, on H, that whole top part is a factor. Right? Factors are what we're multiplying, so we can throw that whole entire thing in parentheses if you would like. You're going to look at your numerator and denominator and see if there's any factors that match up perfectly. And I have a 3 minus 2x and a 3 minus 2x. in the numerator and denominator, so that's going to divide out to be 1. So what do I have left on top? So this is another little tricky one. Is it a 1 or is it a 0 because you got rid of everything? Right, it's a 1 because this 3 minus 2x divided by 3 minus 2x, those are 1s, right? That simplified to 1 over 1 or 1. So what's left in your numerator? 1 over, and then what do we have in our denominator? 4x minus 1, right? We got to come up, with our excluded values. So that's looking at all of the denominators. So we had the 4x minus 1, we know that can't equal 0. And then the 3 minus 2x, we know that cannot equal 0. So I'm going to add 1 to both sides. 4x cannot equal 1. I'm going to divide by 4. We know that x cannot equal 1/4. On this one, I'm going to subtract 3 from both sides. So I'm going to have negative 2x cannot equal negative 3. I'm going to divide by a negative 3. So x cannot equal, negative over negative is going to make that positive, and it's going to be a positive 3/2. So there's my 2 excluded values, and there's my simplified form. All right? So you guys have a couple homework problems to work on. Looking at these types of problems. And if you guys have any questions, make sure you're reaching out to me, and I'll talk to you later. Bye.